Ever wondered how much energy it takes to power the artificial intelligence we use every day? It's a question that's been stirring up considerable debate in the tech world, as artificial intelligence, or AI, becomes increasingly woven into the fabric of our daily lives. One aspect of AI that's been gaining a lot of attention is generative AI. This technology is the driving force behind chatbots, image generators, and a whole host of other applications that we interact with on a regular basis. But as these AI models become more complex and powerful, they also require more energy. And this is where the environmental concerns come in. The truth is, the more powerful the AI, the more energy it consumes. And as we rely more and more on these technologies, the energy demands they pose are expected to rise. But just how much energy are we talking about? Well, that's a bit of a mystery. The exact carbon footprint of AI isn't easy to determine. It depends on numerous factors, such as the energy sources used and the efficiency of the data centers where these AI models are hosted. And right now, there isn't a clear-cut answer. But what we do know is that the global tech sector, which includes AI, accounts for around 2 to 4% of greenhouse gas emissions. That's a substantial amount, and as AI continues to evolve and proliferate, this figure could potentially increase. But it's not all doom and gloom. Many in the tech industry are actively working towards making AI more efficient and environmentally friendly. This includes optimizing energy use, sourcing renewable energy, and purchasing carbon offsets. As AI becomes an integral part of our lives, understanding its environmental impact becomes increasingly crucial. It's a complex issue, but one that we can't afford to ignore. After all, the future of our planet could very well depend on the choices we make today in harnessing the power of AI. Not all AI models are created equal, especially when it comes to energy consumption. Let's take a look at different AI models and their energy appetites. First up is BERT, a generative AI model with 110 million parameters. Back in 2019, researchers found that creating BERT consumed as much energy as a round-trip transcontinental flight for one person. Now let's scale things up a bit. Enter GPT-3, a behemoth of an AI model with a whopping 175 billion parameters. Researchers estimated that creating GPT-3 consumed 1,287 megawatt-hours of electricity and generated 552 tons of carbon dioxide equivalent. To put that in perspective, it's akin to what 123 gasoline-powered passenger vehicles would emit if driven for a year. And that's just for getting the model ready to launch, before any consumers start using it. But size isn't the only predictor of carbon emissions. Let's turn our gaze to the Bloom model, developed by the Big Science project in France. Despite being similar in size to GPT-3, Bloom has a much lower carbon footprint. It consumes 433 megawatt-hours of electricity and generates a modest 30 tons of carbon dioxide equivalent. So, what gives? Why does Bloom have a smaller footprint than GPT-3? Well, the answer lies in the details. A study by Google found that using a more efficient model architecture and processor and operating out of a greener data center can reduce the carbon footprint by a factor of 100 to 1,000, regardless of the model's size. And there you have it. As we can see, the size of the model isn't the only predictor of carbon emissions. Efficiency matters too. It's not just about building these AI models, but also about deploying them. The creation of an AI model marks only the beginning of its energy consumption. Once the model is up and running, every single interaction or query it receives requires energy. When we talk about generative AI, this energy cost can be even higher. Consider this: a single query to a generative AI can consume 4 to 5 times the energy of a typical search engine query. That's quite a leap, isn't it? Now factor in the rapidly growing popularity of AI applications, and the picture becomes even more striking. From chatbots to image generators, AI is becoming a daily part of our lives, and the number of queries these AI models receive every day is skyrocketing. As more and more people begin to rely on AI for various tasks, the energy demands for these models are set to increase. It's a simple equation: more usage equals more energy consumption. And just like that, the carbon footprint of AI deployment begins to swell. But it's not just the sheer volume of queries that's a concern. The complexity of these interactions also plays a part. Generative AI models, with their ability to create complex outputs like sentences, paragraphs, and images, require more energy than their discriminative counterparts. So as AI models become more sophisticated, they also become more energy hungry. This is the double-edged sword of AI advancement. On one hand, we have the incredible benefits of AI, the convenience, the efficiency, the possibilities. On the other hand, we have the growing energy costs and environmental impact of these technologies. As AI continues to grow in popularity, the energy costs of deployment could really add up. It's a reality we must face as we navigate the path of AI development. But it's not a dead end. As we continue to innovate, we must also seek ways to reduce the environmental impact of AI, to strike a balance between technological advancement and sustainability. That's the real challenge of AI deployment. From research labs to everyday use, AI bots have made quite a journey. The rise of artificial intelligence has ushered in a new era of technology, and at the forefront of this revolution are AI bots like ChatGPT. These AI bots have rapidly evolved from being confined within research labs to becoming an integral part of our daily lives. They've been incorporated into search engines and used for a variety of tasks, pushing the boundaries of what we thought was possible. They're not just about searching anymore. They're about creating. They're about problem solving. They're about making our lives easier. Take ChatGPT, for instance. Not so long ago, it was a novelty that few outside of research labs used. But that changed drastically. According to the latest data, by March 2023, ChatGPT had over 1.5 billion visits. By May that same year, Microsoft had incorporated ChatGPT into its search engine, Bing, making it available to everyone. But the capabilities of AI bots like ChatGPT extend far beyond search. They're being used for writing documents, solving math problems, creating marketing campaigns, and so much more. The potential applications are only limited by our imagination. However, as these AI bots become increasingly popular, we must also consider the potential increase in energy costs. Every query, every task performed by these AI bots requires energy. And as the number of tasks they perform increases, so too does the energy they consume. This rise in energy consumption is not without its environmental impact. It's a classic case of a double-edged sword. On one hand, AI bots like ChatGPT are making our lives easier and more efficient. On the other hand, their increasing popularity and usage might be contributing to a growing environmental concern. As AI bots become as popular as search engines, the environmental impact becomes a concern we cannot ignore. It's a challenge that we must face head-on, balancing the immense potential of AI with the imperative of sustainability. The question then becomes, how do we reconcile the benefits of AI with its environmental impact? As our dependence on artificial intelligence grows, so does the urgency for sustainable AI. That is, AI that is developed and deployed with consideration for its environmental footprint. Transparency is key in this endeavor. Currently, the exact carbon footprint of AI can be as elusive as a cat in the dark. We need to bring this cat into the light, so to speak. This means tech companies must be more forthcoming about the energy and resources used in the creation and operation of their AI models. Only with this knowledge can we begin to understand the true environmental cost of AI and start making informed decisions about its use. But transparency alone is not enough. We also need to make AI more efficient. Every question answered by AI, every image it generates, every decision it makes, all demand a certain amount of energy. By refining the algorithms and processes that power AI, we can reduce the energy required for each of these tasks. This is a bit like tuning a car for better gas mileage, the same journey but less fuel burned. Renewable energy also plays a crucial role in creating sustainable AI. If the power used by AI comes from renewable sources, the carbon footprint of AI is significantly reduced. Imagine running that tuned car on biofuel instead of gasoline. It's the same journey, but even less environmental impact. Efforts are already underway to make AI more energy efficient and to power it with renewable energy. Tech companies are optimizing their data centers, sourcing renewable energy, and even purchasing carbon offsets, but more can and should be done. As we continue to harness the power of AI, it's crucial to do so sustainably, balancing the benefits with the environmental costs. Just as we cannot ignore the incredible potential of AI, we cannot turn a blind eye to its environmental impact. The future of AI must be a sustainable one for the sake of our planet and future generations.